Hey YouTube, what's up? You're gonna learn something today. Those are the words of Joshua Bardwell studying many of his videos. And this sentence also applies to this video. I know some do already know everything, some think they know everything, but most of you will learn something today. I learned quite a lot when making this video and doing the motor measurements and comparisons. SCX24 upgrade motors. In this video, I will test 10 brushed upgrade motors for the SCX24 and 3 SCX24 stock motors. I will measure their no-load speed or RPM and amp draw up to 2S, 8.4 volts, and I will measure the torque of the motors and I will compare the results. For RPM measurements, I will use this cheap RPM meter, which works very well, and my lab power supply. I will increase the voltage continuously, check the voltage the motor starts to spin, and then increase the voltage in 0.5 volt steps. I will read RPM at each step from my RPM meter here, and the amp draw from the lab power supply. So I will also check the maximum RPM of each motor at no load and at 8.4 volt, a full 2S LiPo battery. And I will also measure the maximum torque of each motor using this setup here, which some of you may already know from my servo tests and 540 motor test videos. I intended to get a smaller scale than this cheap luggage scale, but couldn't find any. However, this scale seems to work really fine, also in the low kilogram range, and tests went really well. This is a full metal SCX24 gearbox where I mounted the motors, a metal drive shaft mounted on the end here to another SCX24 center transmission shaft, which is mounted here by 2 ball bearings. Here's the rope. I made the measurement. It broke when I tried the Furitech Komodo. And I tested all motors with an SCX24 11-tooth pinion. What's the SCX24 stock motor pinion count, and which came already mounted to the Mofo RC motors in the tests. Some of the upgrade motors do come with 12-tooth pinions or 10-tooth pinions, but I did use the same pinions for all motors for the test, so 11-tooth pinion. In most motors, the pinions held well on the motor shafts only by press fit. However, in some I had to glue the pinion to the shafts using CA for the plastic gears and thread lock for the steel gear here. I'm personally not a really fan of those steel SCX24 gears as here in this transmission. So steel spur gear, steel pinion gear. They are super noisy compared to the stock plastic gears, and the trucks also seem to run smoother, in my opinion, with the plastic gears. I know some of you will ask now, why only brushed, why not brushless motor tests? I'm not the biggest fan of the brushless setup in the SCX24. I think brushed is still the way to go, mainly because the brushless setup is super expensive, not the motors, but motor mounts, gears, and mainly the Furitech ESCs. And I do not like the Bluetooth setup by app, constantly firmware upgrades. Sometimes Bluetooth connection breaks during upgrades or updates. Setup is sometimes quite complicated, quite a lot of problems, and constantly new and expensive motor types, always a better one, new ESC types or ESC types, new firmwares, constantly spending money for, well, yes, for what? My preferred setup is still brushed with a SCX24 crawler ESC by Modellbauregler DE, or for half of the price the tiny AS612RW ESC. However, I wanted to measure and show you guys at least the torque of the Furytech Komodo and also of the Mofo Nano Beast. This sits here in my deadbolt, but I failed. In my first attempt with the Komodo here, the rope broke, what you can see here on video now. That's not a big problem, and then I used 60 pounds fishing line, which should hold up. But then, second attempt, what you can see here, the mount bent and the gearbox made a strange noise and obviously some gears slipped. The problem is not the mount. This mount here, I could make a stronger one. I did also test much stronger, super strong servos and larger motors in a similar setup. The problem is that I do have the first versions of the motor mounts for my Komodo and also for my Mofo brushless outrunner. They are both only 3D printed, and those are the problem. They are not strong enough for such a test. So I would have to buy metal motor mounts for those motors for tests, what I will not do, but probably then something else would break. Drive shaft or whatever. Way stronger than the brushed motors, for sure. But why did I test 3 SCX24 stock motors? Because 2 of those SCX24 stock motors broke during RPM test. Initially I intended to measure no load RPM and amp draw up to 12.6 volts, so a full 3S LiPo. However, both SCX24 stock motors quit working already when only be tested up to 8.4 volts 2S. None of the other 10 motors tested broke. All did the tests up to 8.4 volts without any problems. But because I didn't want to risk and maybe destroy one or some of the upgrade motors when going up to 12.6 volts, I decided to do the tests only up to 8.4 volts. However, I ran several of those upgrade motors in my SCX24s on 3S without any problems. But if you do it, it's on your own risk, of course. None of those motors ran hot during tests. They got only maximum warm. Also, the SCX24 motors, which broke, did not really run hot. I will show you this and the temperature after breaking in a video later using this small infrared thermometer. But what I can already tell you, in the beginning of this video, all those 10 motors are an upgrade to the stock SCX24 motors. 2 SCX24 motors broke in the RPM test. None of the other motors tested broke. I used the third one, still working. One of those is still working. I have several more somewhere. Only in the torque test, and this it survived. The SCX24 motor additionally is the weakest and slowest motor of all those. So unfortunately, the SCX24 stock motor is really poorest quality. Excel should be ashamed. Also, the 2 30-sized motors, upgrade motors tested, outperformed the SCX24 motors easily. I tested 2 30-sized motors and 8 050-sized motors. The SCX24 motor, that's a 030-sized motor, and those upgrade motors are 050-sized motor. Formerly, many people, including myself, named this motor size 180 size, but this is wrong. 050 size is the correct term. 030 sized and 050 sized motors have the same dimensions and shape in diameter, but 050 sized motors are longer and therefore stronger. For mounting a 050 sized motor to the stock SCX24, you will have to cut one leg of the battery mount what you can see here. That's super easy. Otherwise it would be too long. All 0.50 size and 0.30 size motors have a 1.5 millimeter shaft, and you can use them with the SCX24 stock pinion and spur gear. There are also 1.30 sized brushed motors, which, for example, do come in the mini Cs. This is that size. However, they are larger in diameter to have different screw mounting pattern, if they do have a screw mount. Those do not. Those are from the mini C. Here you see screw mounting holes in this motor, and the shaft is also larger in diameter, and mounting those to an SCX24 is quite complicated. You will need extra gears and a special mounting plate like this one, which you can get, for example, from Mofo RC. And here are now the 10 motors, upgrade motors I will test in this video, and 11 motor types. Motor 1 is the SCX24 stock motor. Motor 2, this one I labeled all of them, is the Hobby Plus CR18 0.30 sized 88T torque motor, which comes with the elder Hobby Plus 1-18 CR18 trucks, such as those one with the Lexan Toyota LC80 LC90 style body. Motor 3 is the Mofo RC Torque Beast 30, also 0.30 sized, and that came already with an 11 tooth pinion. And motor 4 is probably the most popular SCX24 upgrade motor, the Barrage motor, maybe the first upgrade motor used in the SCX24. This is 0.50 size, and this one comes directly out of an ECX Barrage 1-24 truck. Motor 5 is the RGT motor, 0.50 size, which is used in the small RGT 1-24 trucks. Motor 6 is the Hobby Plus 55 turns high torque motor, 0.50 size, which comes in the newer Hobby Plus 1-18 CR18 trucks, such as the CR18 Kratos or the CR18 Builder's Kit. And motor 7 is the RocHobby Katana motor. That's this motor here. 0.50 sized, which I took out of my Katana. Probably it's the same motor as used in the Atlas 6x6 and many more of those 1-18 trucks by FMS and RocHobby. I did only take one as an example. And motor 8 is the EazyRC spare motor, 0.50 sized. You can buy this as spare motor for your Patriot, Arizona and whatnot, and it looks quite a little bit different to the Katana motor. And motor 9 is the Injora 66 turns 0.50 sized motor, and motor 10, the new and more expensive Injora 50 turn 0.50 sized motor. The new 50 turn motor should be stronger. However, 50 turn means faster and higher RPM than 66 turns. So the 66 turn motor should be slower than the new 50 turn motor. We will see after the tests. And finally, motor 11 is the Mofo RC Torque Beast 2 0.50 sized motor. Also comes with a brass pinion, Torque Beast. So I expected this motor to be the strongest. We will see. I know that there are more upgrade motors for the SCX24, such as the Ox motor, quite popular over the big pond, and several more motors. I could buy the Ox on eBay, however, shipping and customs make those extremely expensive for us here in the EU, and I won't pay 40 or 50 bucks for a tiny 0.50 brushed motor, so I will not buy and test the Ox motor. All motors here tested are rather new, so no old and faded out motors in the tests. The only quite a bit used motor is the Katana motor. All the other motors run maybe 5 batteries at the maximum, and brand new motors such as the Injora motors I broke in before tests by running them on 2 volts for 10 or 15 minutes. The EazyRC motor does come with a 10-tooth pinion, and the Barrage, the RGT, the Hobby Plus, CR18 and the Katana motor to come with 12-tooth pinions. However, as already mentioned, I used 11-tooth SCX24 pinions for all tests with all motors. Some of the motors do come with a reversed screw mounting pattern compared to the SCX24 stock motor. Here. So you will not be able to mount those directly to the SCX24 gearbox metal plate. What's this one? This will not work, you see. You will either have to drill new holes or buy such an upgrade plate which has 4 mounting holes, as you can see here. The Injora 50T motor does already come with such a plate, and in purple, that's the one I used in my test setup. And the Injora 66 turn motor, you can buy it with or without this plate, and you can buy those plates separately, of course. Here you can see the screw mounting pattern of the test motors. For the Barrage, RGT and Injora motors, you will need such a new mounting plate or drill additional holes. The Hobby Plus, Katana, the EazyRC and the Mofo RC motors you can mount to the stock SCX24 mounting plate without modification. Furthermore, some of the motors do have opposite rotation direction to the stock SCX24 motor. So this is not a problem if you use a non-stock radio gear or the new V2 electronics in the SCX24, where you can simply use throttle reverse on the radio. But it is a small problem if you have the old V1 electronic with the AX4 radio, which does not have throttle reverse. You can simply change motor direction by changing the wires of the motor plugs. Use a tiny flathead screwdriver, pointed forceps or needle to lift this tab on the JST-PH connector, pull the wires out and press them in reverse direction. However, then you have a JST-PH plug with wires red and black in opposite polarity to standard JST-PH plugs. Keep this in mind if you should burn your motor someday. Cut off the wires maybe, and then want to use those wires with plug for adapting a LiPo battery to SCX24. A LiPo that does have different plugs to the JST-PH plugs. And therefore you want to cut the wires and solder the wire to the battery. That is in wrong polarity then. Plus and minus, red and black. You will destroy your SCX24 electronics when plugging in the battery with wrong polarity. So maybe desoldering the wires from the motor and resoldering in reversed direction is the safer way, quickly done, but for sure more difficult than simply changing wires on the plug side. Mofo RC and Barrage and the Injora motors, they turn in the same direction as the SCX24 motor, and the Hobby Plus and RGT and Katana and EazyRC motors, in those you will have to change the polarity. Strangely, the SCX24 motor and the other motors with the same rotation direction, it has soldered the wires in wrong polarity to the motor. If you use the usual red is plus, positive, and black is minus, negative pattern. If you plug the SCX24 motor to a power source, it will run in counterclockwise direction. So in this direction. However, if you plug it to the SCX24 electronics, then it will rotate in opposite, in clockwise direction, that direction. Same for the Barrage motor. And here on the Barrage motor you can even see it. Where is it? The black wire is soldered to the red labeled pole. What is the positive pole? The red dot indicates the positive pole. So that's quite weird. Don't know why they did it. The RGT motor, for example, here you can see that's how it should be. Red, positive red, and black to the non-labeled spot. But the RGT motor, it spins in opposite direction to the SCX24 stock motor. The SCX24 stock motor has quite a short shaft, as you can see here. And some of the upgrade motors do have longer shafts, but of the same diameter. This one, that one, here you can see it. Those motors with longer shafts are Barrage, RGT, the Hobby Plus 55T high torque motor, the RocHobby Katana motor, the EazyRC motor, and the Injora 66T motor. Here you can run into a problem because the shafts touch the gearbox cover here. So you can either drill a small hole into the gearbox cover in the plastic one. In such a metal one it's probably more difficult. Or you can shorten the shaft, what is easy. However, if you should shorten the shaft using a Dremel tool for cutting the shaft or sanding, keep in mind that electric motors are magnetic. There are 3 openings here on the motor on the front side, and swarf can get into the motor and damage or destroy your motor. So if you do so, close those openings before cutting and sanding. That's super easy. Simply use a piece of sticky tape and the holes are closed and nothing can get into the motor and destroy it. And here on this graphic now you can see the motor rotation direction of all test motors and the drive shaft length. Some of the 050 motors, the ECX Barrage motor, the RGT motor, the Hobby Plus 050 55 turn motor, and the RocHobby Katana motor do have the exact same labels on the motor or codes printed to the motor. It's FF 050, so 050 SH 1855. I honestly don't know if this indicates that those are the same motors or if this is only a size or type label. Those prints are not always of the same size. See it here on those, on the Hobby Plus motor. Where is it? So here on this Hobby Plus 55 turn high torque motor, it's a small imprint. This motor is out of the CR18's builder's kit. And here, this motor is a spare motor in my paddy that's out of this bag. Different size of labeling, as you can see. Here it's smaller, here it's larger. Don't know if that means anything. By the way, here's the 10-tooth pinion of the EazyRC spare motor set. The prices of those tiny brushed motors are very different, super cheap ones and expensive ones. However, before the SCX24 was released, those motors were super cheap, such as the RGT motor and the Hobby Plus motors too. I bought those from Asia Tees or Banggood for maybe $5 on promotion, even less. And people who did already play and tune micro trucks before the SCX24 was released know this. But after the release of the SCX24 and start of the hype for this truck, prices have raised extremely because many people including myself, spend a fortune for tuning the SCX24s. But you can still get some of those motors for super cheap, for example, on RC Mart or on AsiaTees. Of course, always also depending on the shipping costs. And now, for 1 year now, for us here in the European Union, depending on taxes and handling charges of customs. The most expensive motors tested here are the two Mofo RC motors. So, where are they? The 30 sized one, and there's the torque beast here, and the 50 sized one. However, actually those are on sale on Mofo RC webpage, much cheaper, and till they are gone, unfortunately. This also is a problem because this means those motors will not be available anymore after clearance sale. Maybe Nick, the owner of Mofo RC, is not able to get the same motors anymore. So depending on what date you watch this video, those Mofo RC motors may not be available anymore. The RGT motor and the Hobby Plus motors, they are already available for many years now. But if those are exactly the same motors with exactly the same specification for all those years and for different batches, who knows? However, quite surprising the prices of those tiny motors sometimes. I guess I paid $5 more for my Torque Piece 2 than I did pay for the 550 Holmes Hobby Scrollmaster Sport motors. And for the price of the Torque Piece 2, I get 3 of those cheap, rebuildable but quite reliable 540 motors on promotion, of course. And for the Injora 50T also, or the Mofo Torque Piece 30, that's the Mofo Torque Piece 30, I paid about the same price as I paid, for example, for the 540 Holmes Hobby Scrollmaster Sport motors. So that's quite crazy with the prices. However, let's stop complaining about prices. SCX24 tuners are willing to pay a lot, and now let's start with the tests. I recharged the LiPo before each single test so that each test was performed with a totally full SCX24 LiPo battery, and I used the same LiPo for all tests because my stock SCX24 batteries are of different quality and one is really bad. During torque test of all those 050 sized motors, my multimeter, this one, showed a very short overload in amp measurements. My multimeter is only able to measure up to 10 amp, but I cannot use my watt meters, the Turnigy one or this one here, since those need a minimum voltage of 6 or 7 volts, and that's not given in the position between motor and ESC. And I want to measure the amp draw of the motor and not the amp draw of the receiver unit. And since the overload was only a super short peak and only once in each measurement, and all other amp values measured with each motor were way below 10 ampere, I ignore those peaks. But keep in mind that there could be a short peak or short peaks higher than 10 ampere in those 050 sized motors. This did not happen in the 030 sized motors. And important, keep in mind, this is no science. That's only the test of one motor of each type with very simple and inaccurate methods. For well-founded statements, one would have to test much more than only one motor of each type, and then there would be still the insecurity if motors of different batches in production all show the same quality. So this is only hobby, and the results show only my result of one test of each motor with my poor setup. But now let's really start. Since RPM measurements of each motor take quite a bit of time and nobody wants to see 2 minutes of each motor test, I will only show you the first motor on film, how I did it, and only the results of the further motors. The torque measurements, however, torque measurement is quite fast, and I will show you the test of each motor in video. So no load, RPM measurement and amp measurement. Motor 1, the first SCX24 stock motor. You can see it here. I show this to you in a short video. Starts at 0.3 volts, 0.03 amps, and 950 RPM. 0.5 volts, 0.03, 7 amps, 1688. 1 volt, 0.064 amps, 3580 RPM, and finally it broke at 8.4 or 8.5 volts. 7.5 volt, 1.13 amp, 23,020. 8 volt, 1.29 amp, 23,600. 8.4 volt, 2S, 1.38 amp, 23,400. 8.5, 1.63 amp, burned. Highest RPM was not at 8.4 volts with 23,400, but at 8 volts with 23,600 RPMs. But after this test and after the motor broke, it was not really hot. I measured the temperature, you can see it here. It had 55 degrees Celsius, 54. Not really super hot. 55. And then I tried a further SCX24 motor, but in the first test I used this large disc, so it's not a totally no load test. And then I continued with smaller discs, and those small discs I used for all further motors. But this didn't help. Here, check the second SCX24 motor tested. Starts at 0.2 volts, 0.022 amp, 636 RPM. 7.5 volts, 0.7 amps, 22,400 RPM. 8 volts, 0.68 amps, 21,000 RPM. Down. It broke already earlier. And after the test, it was even 41 degree. 38 it had degrees. Only 41 degrees Celsius. So this is really poor. This is really poor. But let's check the results here now on some graphs and compare them. So here we can see the RPM results of the first SCX24 motor tested in a graph. On the y-axis the RPMs, on the x-axis the volts applied. Started at 0.3 volts, went up, had its peak not at 8.4 volts, here it did already break. And here the amp measurements of the same motor. Again, x-axis volts and y-axis here the amp draw, but it's easier to compare those in one graph. So here on the left axis the RPM, that's for the full line, and on the right axis the amp draw, that's the dashed or dotted line. And you see the amp draw increased extremely when the motor broke. And here the second SCX24 motor tested, that also broke already at 8 volts or a little bit more. And you can see here the RPMs are nearly equal, so, and at 7.5, 8 volts, those both motors broke. The first one threw a lot of amp when it broke. The second one stopped already here, probably at 7.5, 8 volts. And now to motor number 2, what's the small Hobby Plus CR18 torque motor. I will show you quickly short video of the measurements so that you can see no problem at all. Starts at 0.2, 0.026 amps, 615 RPM. 7.5 volts, 0.58 amps, 23,600 RPM. 8 volts, 0.7 amps, 24,700 RPM. 8.4 volts, 0.8 amps, 25,200 RPM. The Hobby Plus 030 motor started at 0.2 volts and had a maximum RPM of 25,200 at 8.4 volts. And let's compare the results also to the SCX24 motor results in a graph now. So here now the results of the small Hobby Plus 030 motor, RPM, volts, ampere. You see it seems quite smooth, but this graph alone doesn't say a lot. Let's compare it to the SCX24 motors. Here the SCX24 motors in black, dashed or dotted for amp and full line for the RPM, and the Hobby Plus motor in red. And we see RPMs are quite similar, up to about 6.5 volts difference. The Hobby Plus motor did not break, went up to 8.4 volts without any problems, and also did have a little bit higher RPM here. And the amp draw was less than in the SCX24 motors. So here 7 volts, quite a bit of difference of nearly 0.2 amps, and 8 volts up. It increased also its amp draw. So much better result, and most important, the Hobby Plus motor did not break. Motor number 3, the Mofo RC Torque Beast 30, maximum 24,250 RPMs, and it started only at 0.5 volts. And let's check the graphs. And here now the results of the small Mofo RC Torque Beast 30 motor. Again, full line RPMs. Here's the scale, volts at the x-axis, and amps dashed dotted line here on the right side. It started only at 0.5 volts, so significantly later or higher voltage necessary than in the SCX24 and in the small Hobby Plus motor. And the increase of the RPMs is not as smooth as it was in the other motors. This graph alone doesn't show a lot. Let's compare it to the small Hobby Plus 030 motor, and we see this started at 0.2 volts, the Mofo at 0.5 volts only, and the RPM increase of the Hobby Plus motor seems to be much smoother than the RPM increase of the Mofo RC motor. It has a little bit less maximum RPM at 8.4 volt than the Hobby Plus motor, and amp draw at low voltage, the Hobby Plus motor seems to draw less amps, significantly less amps at 0.5 volts, about 0.2 amps. However, at higher voltage, at 8.4 volts, the Mofo RC Torque Beast 30 draws significantly less amp. At 8.4 volt, that's a difference of about 0.3 amps. But the smooth RPM increase of the Hobby Plus motor seems to be much nicer than the RPM increase of the Mofo RC motor. We have to check the torque of those two motors to make a real comparison, but don't forget the Mofo RC motor is way more expensive than the Hobby Plus motor. Motor number 4, the first 050 sized motor, the famous Barrage motor. Check the results in a graph. Started at 0.4 volts, 26,500 RPM maximum. Here the graph of the Barrage motor, dark red, full line RPM, dashed dotted line amp draw. It started at 0.4 volts to spin. This graph alone doesn't say a lot. Let's compare it to the small Hobby Plus motor, the best motor so far. And that's quite a surprise. It seems to be super similar. The Hobby Plus in light red and the Barrage motor in dark red. So RPM very similar at 8.4 volts. The Barrage motor does have a little bit higher RPMs, and it's a surprise. The Barrage motor drew less amps at higher voltage than the small Hobby Plus 030 sized motor. So that's a difference of about 0.2 amps, and it started a little bit later, 0.4 volts compared to 0.2 volts of the small CR18 motor. However, the difference will probably be in the torque. Motor number 5, the RGT 050 motor, started already at 0.2 volts and at 27,600 RPM maximum. And here the results of the RGT motor in a graph, full line RPM, dash dotted line amp draw. This graph alone doesn't show a lot, so let's compare it to the Barrage motor. And we see those results seem to be super similar. The RGT motor did already start to spin at 0.2 volts, the Barrage motor at 0.4 volts. Don't know if that's of any importance, but the RPM lines are super similar. The RGT motor seems to have a little bit higher RPMs, and the amp draw line, that's nearly a copy. So wow, nearly exactly the same. So it could easily be that those two motors are the same motors. They do have the same imprint. The Hobby Plus Torque 050 motor of the CR18s, it also started to rotate already at 0.2 volts and had a maximum RPM of 25,880 at 8.4 volts. And here the results of the Hobby Plus 050 motor in a graph, started to spin already at 0.2 volts. Again, this graph alone doesn't say a lot, so let's compare it to the Barrage motor and the RGT motor. Here RPMs of all three motors seem to be super similar. The RGT motor a little bit higher RPMs, but this could be the same result, and same for the amp draw. Here at 5 to 8 volts, the Hobby Plus motor seems to draw a little bit more amps, but in this setup it could easily be that those three motors are the same motors. They do have the same imprint, but different screw pattern, as you already know. Motor number 7, the 050 motor of my RocHobby Katana, and this did start only at 0.6 volts and had a maximum RPM of 27,850 RPM at 8.4 volts. And here the results of the RocHobby Katana motor in a graph. It did start only at 0.6 volts to spin. Maybe that's also because it's a rather old motor already. And here it has a strange peak, less amps at 8.4 volts than at 8 volts. But this could have been because of my measurements. That's not exact at all. Again, this graph alone doesn't show a lot. So let's compare it to the Hobby Plus CR18 050 motor and the Barrage motor. And again, we see only the start seems to be a little bit different, but the RPM curves are super similar. And the amp draw, the Katana here in light blue, the Katana draws a little bit more amp at low voltage. This motor is older than the other ones, more used, so maybe that's because of this. But beside this seems to be super similar, and the Katana again does have the same imprint as the Barrage and the Hobby Plus 050 and the RGT motor. Only difference, screw mounting patterns of those motors
could easily be that those are the same motors.
Motor number 8, the EazyRC 050 motor. This also started at 0.6 volts and had a maximum RPM of 25,000 at 8.4 volts.
And here the results of the EazyRC motor in a graph. It started to spin only at 0.6 volts. Again, this graph alone doesn't show a lot. Let's compare it to similar motors, to the Barrage motor and the Hobby Plus 050 55T high torque motor. So the EazyRC in dark green here, and there seems to be a little bit of difference to the other motors tested before, to the 050 motors. So the EazyRC motor seems to have lower RPMs. That's a little bit of a difference here. 2000, and it seems to draw higher amps at low voltage but lower amps at high voltage. And it also starts only at 0.6 volts but draws quite a bit of amps in the beginning compared to the other motors. So this EazyRC spare motor for the Patriot Arizona seems not to be the same motor as the 4 motors tested before. It also looks a little bit different.
Motor number 9, the 66-turn Injora 050 motor. It did start at 0.3 volts and had a maximum RPM of 36,000 at 8.4 volts, so much faster than all other motors tested so far, and that for a 66-turn motor.
So here the result of the Injora 66-turn motor in a graph, and what we see, super high RPMs, 36,000 RPM, much higher than the motors tested before, and it also seems to draw a lot more amps. This graph alone again doesn't say and show a lot, so let's compare it, for example, to the Hobby Plus 050 motor, which has 55 turns high torque, 55 turns, 66 turns. 66 turns normally means slower than 55 turns. But what we see here is totally the contrary. The Injora 66 turn is very different to all other motors tested so far. Also check the amp draw. It draws a lot more amps than the Hobby Plus motor and the Barrage RGT. All the other motors, all the other 50-sized motors were very similar so far. And normally you would expect 66 turn lower RPM than 55 turn, but the contrary is the case. So very strange. So let's check what the second Injora motor, which has only 50 turns, should have much higher RPM, will show in results.
Motor number 10, the new Injora 50-turn motor Pro. It did start only at 1.2 volts, so much later than all other motors, and it had a maximum RPM of 27,000.
So here the results of the Injora 50T Pro motor in the graph, and this looks much more like the other 050 motor tested than the Injora 66T motor. But check this. It did only start at super high voltage. So that's very different to all the other motors tested so far. But let's compare it now to the Injora 66T motor. So that's super strange. More for the 66T motor, 50T, much higher RPM than 66T, at least what should be. But this is not the case. But the 50T motor started to spin much later than the 66T motor. That's the only advantage of the 66T motor here. What I see, the 66T super high RPM, and normally it should be the contrary. The 50T should have much higher RPM than the 66T. But let's compare the Injora 50T motor to the Hobby Plus 55T high torque 050 motor, and here we see those are much more similar results. So the Injora 50T motor shows results much more similar to all the other 050 motors tested so far. It only starts to spin much later. And here, dotted, it draws a lot more amps than the Hobby Plus motor, for example. At least at low voltage, starts super late, more than 1 volt necessary to start the motor. At higher voltage, it draws less amps than the Hobby Plus motor. So those are quite strange results. And a fourth graph with the Injora 50T motor and also the 66T motor and the Barrage and the Hobby Plus motor, which show very similar results. And we see the 50T Injora motor in amp draw, highest amp draw of all those normal motors, the 66T super high amp draw, and RPMs more or less in line with the other two motors tested. Normally you would expect that a 55T motor as the Hobby Plus should have little less RPMs than the 50T motor. Let's go back. But the contrary is the case. So the 50T motor has lower RPMs than the 55T, at least at most voltages. At 8.4 volt it does even have higher RPM than the 55T, so that's okay, those results are okay. The not okay result here is the Injora 66T motor, super strange.
And finally, motor number 11, the Mofo RC Torque Beast 2. It started only at 0.8 volts and had a maximum RPM of 27,240.
So here now the graph with the results of the Mofo RC Torque Beast 2 motor. Again, a graph alone doesn't show a lot, but we see it starts quite late at only 0.8 volt. Let's compare it to other motors. Let's compare the Mofo Torque Beast 2 to the Barrage motor and the Injora 50T motor. And what we see, RPMs are quite similar of all those motors. The Torque Beast 2 does even have the highest RPM at higher voltages, but amp draw is quite a bit different. The Barrage motor here, really lowest amp draw at low voltage for sure, and it started way earlier than the other motors, 0.8, 1.2 volts, and the Barrage at 0.3, I guess. And the Torque Beast, the Mofo RC Torque Beast, draws more amp than all the other motors, at least at voltages higher than 5.5 volts. Not a lot of difference here, but Torque Beast. So this motor should be super strong, and the torque tests will show if that's true.
And finally, let's compare all motors in the RPM no-load tests.
So here the results of all motors in one graph. That's not very useful, you can't see a lot. What we maybe can see in the RPM full lines, that the EazyRC motor does have lower RPMs than all other motors, and the 66 turn Injora motor is way above all others. So that motor is super strange. And same, most motors are very similar in amp draw, and only few motors draw really higher amp than the other ones, mainly the Injora motors again. But much better and easier to compare only few motors in one graph. But what can be useful is this graph here, where we have all 11 motors tested and the start voltage, blue surrounding, and the maximum RPMs, red surrounding, of each motor. Here the scale for the RPMs, here the scale for the start voltage, and the 11 motors. So we see the SCX24, the 030 Hobby Plus motor, the RGT 050 and the 050 Hobby Plus motor really started earliest at 0.2 volts. One SCX24 motor 0.2, the other one 0.3. And some motors, such as the Injora 50T, needed a lot of volts, 1.2 to start. And also the Mofo RC motor needed 0.8 volts. There are some in between, and the maximum RPM at 8.4 volts is very similar in nearly all of the motors. Only the Injora 66T motor is way above all others. So not a lot of difference in maximum RPM. SCX24, 030 Hobby Plus motor, 030 Mofo. You see the RGT 050 a little bit faster. RocHobby Katana again a little bit faster. The EazyRC is the slowest of all. And the Injora, that's not a crawler motor. The 50T Injora and the Mofo RC Torque Beast 2, again a little bit higher RPM. So with those results we got so far, we find that there are many motors which are very similar. The ECX Barrage, RGT 050, the Hobby Plus 050 and the Katana motor, super similar, little bit different. The EazyRC, the Injora 66 turn motor, way beyond all others, so probably not a motor for a crawler. I don't know if each of those motors would have such high RPMs. The 50T motor of Injora, the Pro motor, also some special results, as did the Mofo RC Torque motor. And in the 030 motors, similar RPM results. However, SCX24 motors, forget them, they break. And the Hobby Plus 030 motor, the 88T torque motor, seems to be really nicer than the Mofo RC Torque Beast 30 motor, at least at RPM measurements. So finally, the torque measurements will show what motors are appropriate for our needs.
So RPM tests didn't really bring a winner. Many motors seem to be promising. We can sort or exclude from recommendation, of course, the SCX24 stock motors, because 2 broke in the RPM tests, and we can exclude the Injora 66 turn motor, which doesn't seem to be a crawler motor. So torque tests now with this setup will probably bring a winner, or motors that can be recommended. There are some motors with super promising names. So mainly the Mofo RC Torque Beast 2, Torque Beast. Will it outperform all the other motors, or the small Mofo RC, the Torque Beast 30? Will it outperform the other 030 sized motors? But also the Hobby Plus 030 motor is a torque motor, and the Hobby Plus 50 sized motor is also named torque motor, and the new Injora 50 turn motor stronger than the other ones. So we will see. Let's do all the torque tests now and compare the results of all motors at the end. Let's start again with the SCX24 stock motor. 1.88 kilograms at 3.53 ampere. And now motor number 2, the small Hobby Plus 030 sized torque motor. Already 2.28 kilograms at 3.7 amps. And now the Mofo RC Torque Beast 30. .19 kilograms only at 3.3 amps, so not more than the small Hobby Plus 030 motor. And now the ECX Barrage motor, a 50 sized motor. .13 kilograms at 5.37 amps, so significantly stronger than the 30 sized motors. Motor number 5, the RGT motor. .99 kilograms at 5.2 amps. And motor number 6, the Hobby Plus CR18 high torque motor. Wow, 4.88 kilograms at 4.6 amps for the 55T high torque motor of Hobby Plus. And motor number 7, the RocHobby Katana motor. Again more, 5.42 kilograms at 5.37 amps. Best so far. And motor number 8, the EazyRC motor. .06 kilograms at 4.5 amps. And motor number 9, the strange 66 turn Injora motor. .05 kilograms only, but 8.04 amps. Wow. And motor number 10, the new 50 turn Injora motor, the Pro motor. .83 kilograms. Wow, best so far at 7.25 amps, so quite a lot of amp draw. And finally, the favorite, the Torque Beast. Will it be the strongest of all? No, by far not. Only 4.9 kilogram at 6.2 amps. So, no real torque beast. And now let's compare the results of all those motors in the torque tests.
And here are the results of all 11 motors in the torque test, torque in kilogram colored and the amp draw in red. What we see first is here motor number 9, the 66T Injora motor, unbelievably high amp draw, higher, much higher than all the other motors, and the Injora 50T, the strongest motor of all. However, the RocHobby Katana and the Hobby Plus 55T high torque motor also quite nice results. And the Torque Beast, the Mofo RC Torque Beast, not better than many of the other much cheaper motors. The Injora 50T, it's stronger than all the others, pulled more than all the others, but also does draw quite a bit of amps. And the 030 motors here, number 1, 2, 3, the Hobby Plus 030 88T motor is the strongest of all. And the Torque Beast 30 again is not better than the much cheaper Hobby Plus 030 motor, which also runs much smoother, as we saw in the RPM tests. The SCX24 motor, the weakest of all, and as we already know, it breaks very soon. So the ECX Barrage motor and the RGT 050 motor, very similar results. The Hobby Plus 55T motor and the RocHobby Katana, which have the same imprint, are at least in those tests stronger. Amp throw is very similar. The EazyRC motor, weaker than the others. The Injora 66T motor, no crawler motor, but every 050 motor is significantly stronger than all of the 030 motors. So if you want a stronger motor, you should take a 050 motor. However, the Hobby Plus 030 motor and the Mofo RC Torque Beast 30 are options, but not much stronger, and 3 times, 4 times the price of the Hobby Plus motor, the Mofo RC motor. Biggest disappointment for myself are the Torque Beast motors with the strongest names, mainly the Torque Beast 2. Pay quite a lot, and here we have to pay also customs if you order from the United States. And it's about the same as the Barrage motor, the RGT motor, a little bit stronger maybe, but the Hobby Plus 55T motor and the Katana motor were stronger, and they were also better in the RPM tests. So if you want the strongest motor, the Injora one, but good options also the 4 050 motors, Barrage, RGT, and mainly the Hobby Plus and the Katana motor, and also the Torque Beast 2. However, this motor is much more expensive than all the other ones.
So we come to the end of this video, and what did we learn? We learned that the coolest and strongest name doesn't mean the coolest or best and strongest motor is inside. But keep in mind, I did test only 1 motor of each type, only 3 of the SCX24s, so there are uncertainties. It's not science. We should test 10 or more of each type to make profound statements. However, what I saw in my tests, the 030 motors are weaker, of course, than the 050 motors. If you need a new motor for your SCX24 and don't want to mount a 050 motor inside because of the battery mount or whatever, then don't buy the stock SCX24 motor. It's by far the worst motor of all here. It breaks easy. Buy the Hobby Plus 030 torque motor. It's really cheap, and it's even better than the Mofo RC Torque Beast 30, which is much more expensive and does not perform as well. At least this Mofo RC Torque Beast 30 does not perform as well as this Hobby Plus Torque 88 turn motor for the CR18. And in the 50 sized motors, there are quite a lot of good options. What you should not buy if you want a crawler, for sure, the 66T 66 turn Injora motor. That's more a basher motor or whatever. I don't know what to use it for. It's by far the fastest with the highest RPM, and it shows by far the highest amp throw. So this motor, no recommendation for a crawler. But the new 50 turn motor of Injora, the Pro motor, this is the strongest motor of all. So if you want to buy the strongest motor, not necessarily the smoothest, but the strongest motor, then this Injora is the way to go. Draws quite a bit of amp, but that's the strongest motor. And for me, it's a disappointment, the Torque Beast 2. Because it's not the strongest motor and it's so much more expensive than all the other ones. It works quite well, but for example, the Hobby Plus, the 050 sized high torque motor 55T performs better than the Torque Beast 2. So this motor, that's the number of the Hobby Plus motor, is really a recommendation because it's cheap and it's super nice and works really well. The Katana motor was quite strong but didn't perform as well in the RPM tests, and the Barrage motor and the RGT 50-sized motor performed well. Maybe those four are the same motors, but the Katana and the Hobby Plus were stronger in my tests than the RGT and the ECX Barrage motor. So if you want the strongest, buy the Injora 50T Pro motor. If you want to buy the best bang for the buck, buy the Hobby Plus CR18 050 sized high torque motor. The EazyRC was not as good. And if you want the motor with the coolest name, then buy the Mofo RC Torque Beast 2. Thanks for watching, guys. Hope to see you in the next video. I'll be back.